Hi guys, welcome back to Calcfly videos. In this video, we're going to talk about rational exponents. Sometimes you may see them as fractional exponents, as you can see over here, okay? So, fractional exponents is another way to express radical expressions, okay? So far, what we have seen about the exponents or exponential expressions will be, as you know, the exponent was always integer or whole number, like x to the power of 2 or x cubed. If it was the exponent, the exponential expression will be like this: x to the power of -3 or x to the power of -5. But in this case, we're gonna see the exponent as fraction, as you can see over here, like m over n. So we're gonna see x to the power of 1/2 or x to the power of 2/3 or x to the power of 6/5. You can name it a lot. So in this case, let's read this expression. Is very important. It says the denominator of the fractional exponent, so denominator will be 5. In this case, the denominator of a fractional exponent becomes the index or the root of the radical, and the numerator of the fractional exponent, in this case 6, numerator of the fractional exponent becomes the power of the value under the radical symbol or the power of the anti-radical. So basically, this x to the power of m over n is going to transform into radicals like this: n root under the radical form, x to the power of m, and my root is going to be n. Remember that denominator of the fraction will be the root of the radical expression, and numerator is going to be the power, okay, like this. So for example, x to the power of let me do it over here, so let me clean it up. So x to the power of 1/2. So in this case, my denominator is 2, so denominator is going to be my root. So my denominator is going to be my root, and also my numerator 1 is going to be the power of the x. As you can see, this is how it's transformed into radicals. So another example, x to the power of 2/3 will get transformed into radicals like this. In this case, my denominator is 3, so my denominator is going to be my root of the radical form, 3, and my numerator is 2, so my numerator is going to be the power of the x. So the denominator will get transformed over here, and numerator will get transformed over here as the power of x. Okay? So this part is very important also. It says all rules that we have learned for the exponents. Remember that in the previous video, we've talked about 6 exponent properties, like product rule, quotient rule, power of a product rule, power of a quotient rule, negative exponent, and power rule. So all rules that apply to exponents will also apply to fractional exponents. So this is very, very important. So we're gonna take it into consideration whenever we have expressions involving fractional exponents. Alright guys, let's try to practice what we have learned so far. Let's put everything that we have learned into motion. In the next slide, we're gonna solve 3 problems. And the first problem, what I see is -64 to the power of 2/3. So we need to put this expression in the simplest form. So what can we do about this? Let's think about it. So, -64 can be written as -4 times -4 times -4, right? Another way, it's going to be equal to -4 to the power of 3, because we see that -4 is being multiplied by itself 3 times. So -4 will be the base, and how many times we multiply -4 by itself will be my power. So -4 to the power of 3. So instead of putting -64, I'm going to switch it with a -4 to the power of 3. So let's do it. -4 to the power of 3. So this is my power. And also we are raising this power to another power. In this case, it is fraction, 2/3. So remember that it's time to apply the power rule. What do we do to apply to power rule? We multiply these teeny tiny exponents. So -4 to the power of 3 times 2/3. So as you can see that these 3's are going to be simplified, and what I'm going to be left with is -4 to the power of 2. So this is also equal to -4 times -4. We're multiplying -4 by itself twice, so the result will be 60. Okay, let's say instead of simplifying this expression, you would like to convert this fractional exponent to the radicals. In this case, check this out. My denominator will be the root of the radical, and 2, which is my numerator, will be the power of -64. So it's going to be equal to, my root is 3, and numerator will be the power of the -64, which is going to be like this. So the cube root of -64 squared. This is how you read it. Okay? Alright. Let's move on to question 2. In question 2, we got a negative fraction as a power. Okay? As a power. So what do we do in this case? So I'm going to give you a quick note right here. Quick note. So whenever you have negative exponent for the rational numbers, so you're going to switch things. Like you're going to flip numerator with denominator. Okay, so you're going to turn it upside down. Okay, so this expression is going to be equal to 25 over 81 to the power of 2/3. So when I flip things around, I'm gonna also turn to negative exponent into positive exponent. Okay, so my rule, a over b, and we are raising this a over b to the negative x over y, let's say in this case. So this is going to turn into, along with positive exponent, b over a to the power of y over x with positive exponent. Okay, that's what we did right there. This is the quick note, or you want to call it rule. Okay, so we know that 25 is 5 squared and 81 is 9 squared. So basically, I can also write this down, this expression, as 5 over 9 to the power of 2. Okay, and also we are raising this to the 2 over 3 power. Okay, so in this case, again, we're going to apply the power rule. So we're going to multiply these two teeny tiny exponents. So the result will be 5 over 9 to the power of 2 times 2 over 3. Okay, so there's nothing to be simplified, so 2 times 2 is 4, so the result will be 5 over 9 to the power of 4 over 3. If you'd like to convert this expression into radical, so your denominator will become the root of the radical, so it's going to be equal to, like this. So this is going to be 3 and 5 over 9, and then your numerator will be the power of this fraction. This is how you convert it into radical form. Okay. So let's move on to question 3. In question 3, so we're given this, let's say, algebraic expression involving fractional exponent, as you can see. And we're going to be evaluating this expression when a is equal to 8. So what we're going to do is, first, we need to deal with this expression. So by applying the power rule. So a to the power of 2/3 times 5 over 2 and plus a. So a to the power of, so these 2's are going to be cancelled. So a to the power of 5 over 3 plus a. So now let's plug in 8. So we get 8 to the power of 5 over 3 plus 8. So we know that 8 can be written as 2 times 2 times 2, or 2 cubed, right? So basically, instead of 8, I'm going to switch it with 2 cubed. So 2 cubed to the power of 5 over 3 plus 8. So if I multiply these two powers, we get these 3's being simplified. And then what I'm going to be left with is 2 to the power of 5 plus 8. So 2 to the power of 5 is, I'm multiplying 2 by itself 5 times, so it's going to be equal to 32. and we got also 8 being added, so the result is going to be equal to 40. So when I evaluate this expression, when a is equal to 8, result is going to be equal to 40. Alright guys, in this video we talked about fractional exponents, and we talked about also how to convert fractional exponents into radical forms, and we've solved 3 problems. Hopefully you understand better. So please stay tuned for the next video, because in the next video we're going to talk about how to simplify radical expressions. If you like this video, don't forget to subscribe, like, share and comment. In the next video we're going to talk about how to simplify radical expressions. See you in the next video. Bye bye.